first step and then second step. Ethyl bromide. So we deprotonate the thiol and then it could attack the bromine. I mean the halide, sorry. So we could then make that kind of compound, which is a sulfide. Otherwise known as a thioether. So that's like the sulfur analog of an ether. You can make by alkylating a thiol. Now here's how you know that sulfur is very nucleophilic. Because you can actually take that thioether or sulfide. Let's draw it. Put it in the presence of an appropriate alkyl halide for doing an SN2 type of substitution. So put it in there with more of that stuff, and it will actually do another SN2 type of substitution because it's just that special. So you make here a species known as a sulfonium ion. Which in this case would be balanced electronically by your bromide anion that you keep going. So it's a sulfonium ion or sulfonium salt in combination with an anion. And these sulfonium salts actually make good alkylating agents themselves, right? So for example, if you have that sulfonium ion, or even the one that we formed there, they can be used very effectively as alkylating agents. So say for example, if you had something like butyllithium. So butyllithium we can draw analogously like having a carbon that's negatively charged, so it behaves as if it's a carbon. So what will happen is the electron pair from butyllithium, however you want to draw it, you could draw it this way, oops, or the pink way. Could attack one of these methyl groups, and the less substituted the group, the better the attack would be. Because this is an SN2 type of thing. So if I did that, I would have ended up extending my alkyl chain in this particular case and giving off dimethyl sulfide as my leaving group. So just to give another example or two, or one. So any anion that's a good nucleophile could get alkylated using dimethyl sulfide. Using this kind of sulfonium ion. And in your book, they show it as, so I actually looked in your book. So I should feel proud of myself.
Yeah.
I don't remember if it was this sulfonium ion that they used, but they used it as an alkylating agent to alkylate pyridine. And release dimethyl sulfide. And then one other thing that sulfides do for a living that's synthetically kind of important is if you take a sulfide like, let's make up a sulfide, and you treat it with hydrogen peroxide usually in acetic acid. These are conditions that oxidize sulfides, and it kind of does something that will look weird to you if you try to think about doing something similar to alcohols, to an ether, right? Because in oxidizing a sulfide, if you did it once, you get a species like that, which is called a sulfoxide. And the interesting thing about sulfoxides is that you can actually write an alternative resonance structure on this.